In this video, I want to talk about these different types of equations for lines. I'm going to be talking about the general or standard equation of a line, and I'm also going to talk about something called the slope point form. Now, all of them represent the equations of a line, and they all are basically the same thing, and they're just different ways of expressing it. So I'm going to reuse one of the examples I had from my previous slope y-intercept form because a lot of the information is still relevant, and I want to just be lazy and be able to reuse some stuff without actually having to rework out a new example that's generally irrelevant anyways. Okay, so we have a slope y-intercept form, and we also have a general form, and I'm going to just write it out here. Okay, so the general or standard form is such that ax plus by plus c equals 0. Okay, and that's basically what it is. Okay, so it's ax plus by plus c is equal to 0. Okay, now basically what we're going to do with this standard slash general form is we are going to come up with an equation using slope y-intercept form, and then just kind of massage that equation to make it look like the general standard form. Okay, so that's another important one there. And this is the reason why I kept the example from previously, the previous example, because I'd have to work out a new one anyways. So I just figured I would just reuse this, and that way I wouldn't have to come up with a new example. Okay, so from our previous example, we are given something like this. Y is equal to 2x plus 2, or 2/3 x plus 2. And this is given in the slope-intercept form. Now I'm just going to write it over here a little bit neater. Okay, so y is equal to 2/3 x plus 2. Okay, now one of the things is the general or standard form has all of the terms pushed over to one side. Okay, and they're not actually pushed, but all the terms represented on one side. So what I have is I have y is equal to 2/3 x plus 2. And what I'm going to do is I'm going to subtract y from both sides. So I'm going to do negative y plus y, and over here I'm going to put in a negative y. So I put a negative y on both sides, and I can do that as long as I do it to both sides, and that way I don't alter the equation. These two cancel to get 0. So I get 0 is equal to 2/3 x minus y plus 2, and they're all, if it's equal to 0 on this side, it's equal to 0 on the other side. Okay. Now, one of the things is the general or standard form has to have no fractions. Okay, so what I'm going to do is multiply everything by 3, okay, to get rid of this fraction. So this would become 2x minus 3y plus 6 is equal to 0. Okay, and the other thing you have to look for is that usually this term here, okay, is positive. Okay, so if it was negative, then I would have to multiply both sides by -1 to make it into a positive one. But in this case, it's already positive, so I don't have to do anything. Okay, and so the general slash standard form of that same equation is just like that. Okay. Just to comment on that, actually, it's pretty easy. Basically, whenever you're given a problem, you basically just find out the slope y-intercept form of the equation, and then just move all, or just represent all the terms on one side of the equation, get rid of fractions, and make sure the first term is positive, and then you're in the general slash standard form. Okay, the last form is something called the point slope form. Okay, so the point slope form. Okay, and the way the point slope form is that it's represented like this: y2 minus y1 is equal to m times x2 minus x1. Okay, now that's basically the point slope form. I'm going to show you how we get this. Okay, and this is actually just a result of the slope formula. Okay, I'm just going to put a rectangle around it to show that it's an important one. Okay, now the equation for slope, m, is equal to the change in y over the change in x. Okay, now the change in y over the change in x is y2 minus y1. And the change in x is x2 minus x1. And so what I can do is I could consider these to be each their own term, right? And then I can multiply both sides of this equation by x2 minus x1, and I'd get x2 minus x1 times m is equal to y2 minus y1. Okay, and you can see that is the same as that. Okay, and that's how we get that. Now, one of the things for a point slope form is that you have to know one of the points, and you also have to know the slope of the line. So if you don't know the slope of the line, then you basically can't put anything into point slope form. Now, in this example, I do know the slope of the line, and I do have two different points. So what I'm going to do is choose one of them, and in this case I'm going to choose B because both of the terms are positive, or both of the coordinate pairs, all the coordinates in this coordinate pair are positive. So I'm just going to use that. And the way you represent it is by just substituting one of the values in for each one. So what I'm going to do is I'm going to say y2 and x2 are just generic values. y1 is now 4, and y2 and x1 is now 3. Okay, I'm just going to substitute those in. So I'm going to say y minus y1, which is 4, is equal to m, which is the slope, 2/3, times x minus now x1, which is now 3. Now I leave the y and x the same because those are just unknowns in the equation. And that's it. That's the slope point form. Now, an observation that you should have is noticing that the slope point form, or the point slope form, can take many different forms depending on the point that you choose to use along with the slope. That's totally fine. And I'll show you why. If I take this and I say y minus 4 is equal to 2/3 x minus 3, and I'm just going to simplify and combine like terms. Okay, now normally we wouldn't do this for point slope form, and I'll show you. I think it'll become apparent why, so just bear with me here. I'm going to y is equal to 2/3 x minus 2/3 times 3, so I have to multiply this 2/3 by each term inside the brackets, and then add 4 to eliminate this 4 here. So let's see what I get. Y is equal to 2/3 x minus, now 2/3 times 3 is just 2, plus 4, and I get y is equal to 2/3 x plus 2. Okay, now you should notice something about that. Okay, is that these two equations are the same thing, and you're going to get that every time you try and simplify the point slope form. And of course it makes sense because it's the same equation representing the same line, it's just in a different form. Okay, so that's why we don't expand and simplify the point slope form. Okay, now the point slope form is actually really simple then, as long as you have the slope of the line, and as long as you have a single point, then you can just plug it in and get the point slope form. And then from there you could resolve that into the slope y-intercept form, and you could find the y-intercept. Alright, so it's just an easier way of doing it. Anyways, that's pretty much it for point slope form and also the general standard form. They're all related to each other. They're all basically representing the same thing. They're just different ways of massaging the equation to look different depending on your needs. So anyways, if you do have questions about this, please feel free to send me an email or drop a comment in the comment area. If you do like the video, please toss me a thumbs up, and if you do like the channel, then please consider subscribing.